Okay, so what we're going to do here is we're going to start solving systems, but we're going to use matrices. So we're going to see how we can actually make life easier when we have a system of multiple variables. You know, we've solved a linear equation with x, y. You get multiple variables and allows us to easily solve a system using matrix. What we're going to do is, I'm sorry, this is a little blurry, but we're going to start by writing this as a matrix equation. And so the way that we do this is we look at our linear equation, okay, and so this is a system and there's three variables, A, B, and C. And notice here we have a couple different things here. I have a gap right here. We want to make sure that, notice we have all the A's right here, we have all the B's right here, and we have all the C's right here. And so I'm using that setup because I want to make sure that everything's lined up just like you would if you were solving a system with X and Y. And so really what I'm going to do is I'm going to just kind of create a matrix that kind of just looks like this. But I want to make sure that the variables are consistent. So for this spot, there's nothing there, so that would be 0. So I'm writing the coefficients, and I write the coefficients and get my my matrix system set up. And so the coefficient for this guy right here is -1, and then I have a +2. So I'm going to just write the coefficients, and then we'll go from there. So 1, 1, -1, I'm just going by row. 2, and then I got a 0 in this spot, and then I got a 3. And so my matrix equation, so this is my coefficient matrix. Okay? And so then if I multiply this by A, B, and C, that's going to equal my solutions, which are 4, 0, and 11. So these are my solutions, and then these are my variables. Okay, and now think about matrix multiplication. If I take a 3 by 1, right, that's what this guy is. This is, or excuse me, a 3 by 3, and multiply it with a 3 by 1, it's going to equal that's going to equal a 3 by 1. And so notice, what's this? It's a 3 by 1. Okay? So it's going to equal this guy. So if I take 0 times A, well, that's this piece right here. -1 times B, that's this guy right here. 2 times C, that's this guy right here. And that corresponds to this 4, which is equal to 4. So this outer dimensions is going to equal this guy right here. So that's how I would set up a matrix equation. And so what I'd like to do is, the way that we can solve a matrix equation is by following these steps. So we're going to solve the system using a matrix equation, so I need to set it up in a matrix equation. What we have to do is we need to, 1, find the inverse of the coefficient matrix, and then multiply that by the constant matrix. And then the result is our answer. So let's go ahead and set this up. So the first thing I'm going to do is I'm going to set up a matrix equation. So I have 2, 3, 1, 2 times x and y, right? That's my variable matrix. And that's equal to 11, 6. Okay? So I need to find the inverse of the coefficient matrix. So that means this guy right here is the coefficient matrix. Okay? And then I'm going to go ahead and find the inverse of that. And then I'm going to multiply that by the constant matrix. Okay, and the result is my answer. And so we'll go ahead and go through this. Okay, so this guy right here is our constants. Okay, so really I have A times X is equal to B. So X is going to equal A inverse times B. Okay, so we're going to get a little bit of practice here because we need to do some of this stuff by hand, and then I'll have another video where I do the same example, but I use a calculator. Okay, so I need to find the inverse of A and multiply that with B. So A inverse is going to equal, I need to find the determinant, right? So it's 1 over the determinant times D, negative B, negative C, A. So that's how we find the inverse of a matrix. And so I need to find the determinant of A, which is going to equal 2 times 2 minus 3 times 1. And this one's kind of nice because I get 4 minus 3, and so I get 1. So A inverse, I'll go ahead and shrink this a little bit, move it over. I'm going to go over to the right here. So A inverse was equal to 1 over the determinant times, and this is our little switcheroo here, I need to take the coefficient matrix and switch these two guys to the same numbers, which is fine, and make these guys opposite. So A inverse is equal to 2, negative 3, negative 1, 2. I then take that, and x is going to equal, as I said before, the inverse times the constant, or the solutions, right, 11 and 6. So I'm going to take 2, negative 3, negative 1, 2, and multiply it with 11 and 6. And what's nice is our calculator can do all this, but it's a good review to go over matrix multiplication and finding an inverse. So I have a 2 by 2 multiplied by a 2 by 1, and so the result is going to be a 2 by 1. So I'm going to find this spot and this spot. So I'm going to take wrong piece here. Okay, I'm going to go ahead and rewrite that because I removed it, but okay, there we go, there we go. Okay, so these are the two spots. So to find row 1, column 1, I'm going to take row 1 and multiply it by column 1. So I get 2 times 11 plus negative 3 times 6, and that's negative 18 plus 22. So we got a negative 18 plus 22, so that's going to equal 4. And then I have my last row in column 1, so negative 1 times 11 plus 2 times 6. And so that's going to equal 1. So I have 4 and 1. So my solution to this matrix here, I'm changing my pen color real quick. So the resulting matrix that I got from doing this multiplication was 4, 1. And so notice these were my x values and these were my y values. So what that means is this is x and this is y. So x is equal to 4 and y is equal to 1. And so what we've done here is we've solved the matrix, and if we solve this linear system by using substitution or elimination, we get the same answer. But using this matrix allows us to also solve. And what's nice about this is we can actually see any system and use matrices to do this. So when you see how to do it on the calculator, excuse me, it's a much easier process.